You have the option of changing that disk partition style at a later time if you want. You can convert from MBR to GPT. Some considerations here. If you're on a BIOS system, not a UEFI system, then the system partition, which is the partition that contains the boot files, that partition will have to be MBR. Okay? Only UEFI systems are going to support booting to that GPT. GPT is always supported for data disks, though. As I said, the general recommendation is you use it if you need partitions greater than 2 terabytes. That would be about the only time you would really have to convert. Now, if you are going to convert from MBR to GPT, you do have to be an administrator or a member of the backup operators group. You have to, or you should, not have to, you should back up data first. I've never seen one fail personally, but it doesn't mean it can't happen. The disks must be online in order for you to do it, so they can't be in an error state or taken offline. And this is a one-way process. I mean, you can go back, but if you go back, you have to wipe all the data. I don't know why you would go back, but that's the way that it is. So if you want to convert, have a good reason for the conversion, do a backup, and then you can do the conversion. I can do that both in disk management just by right-clicking on the disk and choosing to convert, and I also have the convert command over in DiskPart and a commandlet in PowerShell as well. When you're using MBR disk, you have another distinction between the two different styles, and that distinction is between basic disk storage and dynamic disk storage. Dynamic provides additional functionality. With dynamic volumes, you have the ability to extend or shrink volumes. You also have the ability to create multiple volume types. Simple, spanned, mirrored volumes, striped volumes. You have the ability to repair mirrored volumes. You have the ability to reactivate missing or offline disks. There's no limit to the volumes it can create. Basically, at this point, any type of multi-disk volume is going to be a dynamic. And this was something in the past where you had to make a choice because if I had it listed as basic, then it wouldn't give me the volume options. And so I'd have to convert it from basic to dynamic in order to be able to create these multi-disk volumes. Now, that's not the case. Now you create partitions or volumes, and it gives you all the options. And if you decide to create a multi-disk volume, that is a volume with one drive letter that spans multiple physical disks. If you try to do that, it'll do it, and it'll just convert the disk to dynamic for you. So it's just kind of less of an ordeal now. We can just talk about the fact that in Windows 10, you do have the ability to create volumes that span multiple physical drives, and they can come in a couple of different styles. It's called dynamic disk storage. If something goes wrong with one of those drives, disk management will give you the ability to repair, to reactivate. So it is advantageous. The only time dynamic disk should not be used is in a multi-boot scenario. So if you're dual booting between Windows 7 and Windows 10 or Linux and Windows 10, you don't want to use dynamic disks because the dynamic disk is only readable to the operating system that's actually using it. And it's because it puts a little dynamic disk database on the drive itself, and that's unique to that particular computer. So these different volume types are something that we want to know. The first volume type is simple. A simple volume is contiguous space on a single disk. That's just your normal type of, what we would call a basic partition as well, a simple volume. It's assigned a drive letter or a mount point, but it's not fault tolerant. It doesn't have any increase in performance. The conversion to dynamic, as I said, is going to happen automatically. Now, you can extend simple volumes. If there's unallocated space, I can extend a simple volume to take up that unallocated space. As long as you don't extend it onto another physical drive, it still remains a simple volume. A spanned volume is our first multi-disk volume. So this is a single volume drive letter, but it's taking up space for more than one disk, at least 2. It also, though, does not provide any fault tolerance, and it does not provide any increase in performance. A span volume is simply to extend the amount of usable space. So if I create a volume on one drive and then I span it onto another physical drive, it's going to fill up the first drive before moving on to the second drive. Okay? It's not writing things to both drives at the same time. It doesn't have any fault tolerance. Span volumes is really just an extended volume across multiple physical disks. So usually we just do it if we've run out of space. I go buy another 500 gigabyte hard drive or terabyte hard drive, but I don't want to have another drive letter, so I just extend an existing volume onto that other drive. I mean, that's a good reason, probably about the only reason, to create a spanned volume. Another type of multi-disk volume is called a striped volume. Now here we're getting into RAID levels. RAID is a redundant array of independent disks, and the RAID, the R, stands for redundancy. Okay? That's why it's weird that striped volumes are part of RAID, although it's RAID 0, so I just remember always that it's 0 redundancy. A striped volume is going to use an identical amount of space on 3 or more disks. And what it's going to do is it is going to write data simultaneously to the different disks. It will write it in little chunks, so little 64 kilobyte chunks of data. So I've got disk 1, 2, and 3, and so it writes, you got a 2 megabyte file, it breaks it into however many pieces it needs to for a 2 megabyte file, and it writes them in little 64 kilobit chunks across the different drives. Well, the effect of that is that, it's doing it simultaneously, and so the disks, instead of having one drive that's doing everything, you have 3 drives. So you clearly increase your throughput because the read-write heads can get set up while I'm writing the first chunk. We're setting up on the second disk. While I'm writing on the second disk, we're setting up on the third. It is going to provide faster performance, but it does not provide any fault tolerance. And it's a little bit scary because if you've got one drive and you're dumping everything on one drive, then you have a certain expectancy of failure at some point. Okay? If you've got 3 drives, then you just tripled your expectancy of failure. You made it 3 times more likely that you might lose a drive, right? I mean, that's basically just the way it works. So on the one side, I'm increasing my speed, but I'm actually decreasing my chances for reliability. And because I have no fault tolerance, don't know that it's a great thing. You would definitely want to be backing it up. Typically, striped volumes are only getting used, for database drives, something that really requires a high level of throughput. A mirrored volume is RAID level 1. This is using 2 identical dynamic disks, and it duplicates the data across both of those drives at the same time. So this provides fault tolerance. It enhances read access because you can read off of both of them. It is predominantly for redundancy, though. If I lose a drive, I have an identical copy on another volume. And so from a redundancy perspective, there really isn't anything that matches the mirrored volume. Every volume that you create is going to have one of 2 things assigned to it, assuming that you actually want to access it in File Explorer, which is kind of the point. That's a drive letter or a mount point. Now, a drive letter is the typical way of doing it. So we've got the C drive, and if I had an additional hard drive, I might call it, D or S for storage or whatever drive letter is available. You can call it whatever you want to call it. But another option is a mount point, and the mount point provides a little bit more flexibility. A mount point is also called a drive path. It's basically just instead of a letter to assign to this, you're going to assign a folder reference to it. Okay, so I create a folder on my C drive and call it storage. And then I assign the mount point C:\storage to this physical drive. What that means is I'm accessing it like it was a separate folder on the C drive, but in reality, it's a different physical disk. Well, if I have a C storage folder that's actually mapping to a 2 terabyte drive, you can think of how much easier that it makes it for saving files, for installing applications, those kinds of things. They can be installed off of the C drive, but still have the flexibility of being able to access it like a folder. And the partitions can have both. It's just usually a one or the other thing. It's also something that can be modified down the road if you wish. Another management operation that we can perform on volumes is resizing them. You can shrink a volume, you can extend a volume, you have complete flexibility with doing that. So if you're shrinking, it would create potentially additional space for use by applications or data. Simple and span dynamic disk, with a simple volume, you can extend on the same dynamic disk. On a span volume, you can extend to another disk on the same computer, and you can always shrink. If you shrink, you're freeing up space, you're creating unallocated space, so that then, presumably, you can create a volume in that space. There are a couple things you should do before you shrink, and that would be defragment the disk and try to move any page files. Okay. Defragmenting just makes sure that you're getting everything back to where the data that it makes up a particular file or program is all together. Things work better that way. You're actually going to be able to shrink more if that is the case. All right, let's go back into disk management and we'll take a look. Go this route this time. Okay, we're going to take a look just at the some of the options that we've got in here. Let me get rid of this volume. Okay, so right now, if I go into File Explorer, just to be clear here, if I go into File Explorer and hit PC, I've got a C drive. That's all I've got. We've got a couple of partitions here, but they're recovery partitions, and they don't have drive letters. So if they don't have drive letters, they don't show up in File Explorer. Okay. Now, first thing first, I mean, this says basic, but I'm getting the options that I would with a dynamic disk, like add mirror or extend volume. So I'm going to extend the volume, and I want to extend it to take up the rest of the space on this drive. Hit finish, done. All of a sudden, you know, I have to refresh, but now I've got 126 gigs. And I've got 116 gigs free, okay? So I just extended it very easily, and I think most of the time we've got one, a larger drive or a larger partition that is your C drive. Okay, we've got a couple of other disks here. We got two 500 gigabyte disks, and we've got a 2 terabyte disk. Let's go to the first here, and we're going to create a simple volume. Just going to take up the entire area of space. Give it a drive letter, S, call it storage. We're going to do a quick format of the NTFS file system. Get the FAT file system as well that you could do, but we're always going to be using NTFS at this point. Now, as soon as we do that, then S storage shows up, right? It's 500 gigabyte partition. If you change drive letters and path, I'm going to remove that drive letter. And then I'm going to go in and say, you know what, let's do this as a mount point instead. So we're going to browse on the C drive. We're going to create a new folder called storage. We're going to say, okay. Now it's not listed here, but when I go in here, I've got a link to storage, and it actually does give me the size there. Okay, and if I were to right-click and go to Properties, on this, it's showing me that it is a mounted volume. If you hit Properties there, it's going to show you, use space and free space, and the fact that it's an actual physical disk. But it's being accessed like a folder. Okay? So that is the mount point. That's why that is beneficial. I can create a span volume by right-clicking this and just saying I want to extend. Okay, and then I say, okay, I want to extend it onto disk number 2. Hit finish. It's going to convert them to dynamic disks. All right, our legend now shows a spanned volume on those 2 disks. And it's still C storage, only now it's a terabyte. And it'll fill up disk 1 before it moves on to disk 2. Okay, so let's delete that. The other option would be a striped volume. If I say a striped volume, it's going to have me choose the disks that I want to use. okay, and then create that volume. And I actually did that to test myself. I had there was a misprint in the slide. It's not 3, it's 2. So stripe volume's at least 2 disk and a maximum of 32, okay? Not like you'd have 32 drives, but you at least have to have 2 drives, and then it's creating and formatting. And what will happen is, I mean, that will be, well, once it's done here, that will be a drive that is a terabyte in size. You're not really losing anything because you're not getting any redundancy, okay? If you want to add some fault tolerance to the C drive, you can add a mirror. You can choose disk 3. On disk 3, I want to add a mirror. Oh, you know what, though? That one is GPT, I believe. No, that one's an MBR. Oh, I see. It is, this one is, aha. Okay. So the C drive was, or that disk was configured as a GPT disk, which means I have to convert this one to a GPT disk in order to be able to add the mirror. And that'll give me that redundancy that I hope to have, okay? At this point, what that would be doing is it would be copying anything on that drive to the other drive, and that's going to take a minute there. It'll go through resyncing. Basically, it just created a partition on it. You could use this. I mean, ideally, if you're going to use a mirror, the drives are the same size. Ideally, if you're going to do striping, the drives are the exact same size, and you're using the entire drive. Don't have to, but that is really the best way to do it. Just a couple of other things here. I mean, if you see something like this where there's an exclamation pointer or whatnot, when you right-click here, there's a couple of things that can be done. Now, right now, this is just because it's resyncing, so I'm not going to worry about it. But reactivate disk. If you've got a drive that's showing up and looking like it has a problem and maybe not accessible in File Explorer, then reactivating the disk really is the first step. It's kind of just a software method of trying to get the disk up and running. Now, if it starts happening all the time, then you probably need to look at getting the data off there and replacing that disk. Import foreign disk is something that you would have to do if you move a dynamic disk from one computer to another. And it's because that dynamic disk database that is unique to the computer that it's actually sitting on. And so you can move them, but when you right-click and import that foreign disk, it'll show up as a foreign disk. When you import it, it'll replace the dynamic disk database on it with the one from the computer, that you're moving it to. Okay? And so anyway, reactivate and import, those are a couple that you typically have to do. Sometimes if a disk shows up offline, then you just right-click and you'll just choose online. This one, because it's online, it says offline, and if it was offline, then it would say online. So it's a toggle type of thing that you can modify, all right? And you can use DiskPart or PowerShell for any of that, but disk management, we're usually doing it infrequently enough to probably just use the graphical utility.